Good morning. My name is Maria Eduarda. My advisor is Otávio, and my presentation is entitled Wind Speed Controls on Scalar Gradients and Fluxes in the Stable Boundary Layer. So the presentations contain introduction, objective, methodology, and some results. So the boundary layer is the part of troposphere that is directly influenced by the presence of the Earth's surface. This portion responds to surface forcings, which with a time scale of about an hour or less. These forcings include frictional drag, evaporation, transpiration, heat transfer, pollutant emission, and terrain-induced flow modification. The boundary layer thickness is quite variable in time and space, ranging from hundreds of meters to a few kilometers. The importance of this study. The quantification of scalar fluxes between the surface and the atmosphere has become in the past decades a major application of boundary layer meteorologic knowledge. The scalar exchange depends on the availability, intensity, and spatial distribution of source and sinks, but also on the structure of turbulent flow, which is the most important physical mechanism that promotes the exchange between scalars from the surface to upper levels in the atmospheric boundary layer. Sensible and latent heat fluxes are the dominant components of the energy budget in most places. Their correct determination is important in both weather and climate forecast models, and also for hydrometeorological applications. The objective. So the main goal of the present study is to describe how gradients and fluxes of sensible, latent, and CO2 change as the mean wind speed decays in the stable boundary layer. This is done using a data collected at a coastal site in southeastern Brazil, where the mean wind speed systematically decays along the nights. So, the experimental site is located in Linhares, Espírito Santo, approximately 4 kilometers from the ocean. The instrumentation fixed to the tower and used in the research is CO2H2 atmospheric profile that measures the concentration of these gases in 6 levels in the atmosphere. And to determine the scalar fluxes, how sensible, latent, and CO2, the edge covariance technique was used. So for measuring these gases, density of water and CO2, wind speed and temperature, air temperature, all statistical moments of turbulent quantities have been determined using a time window of 30 seconds at 20 meters. So I bring one case. In the upper panels, left to right, the air temperature, H2, and CO2 densities, and below your respective fluxes. The red line are the mean fluxes. In the midnight, the large wind speed is enough to mix the scalars, causing the reduce of all gradients in large fluxes. After midnight, these patterns changed. and large vertical gradients, all scalars, were established for these scalars. So the fluxes in the second portion of the night become intermittent and marked by an irregular succession of events with finite and near zero. So here I have the average of 9 nights gradients and mean wind speed in 9 levels of measurements. So I have the minimum wind speed on each level to there is mixing in the layer to each scalar. The similar results found by Acevedo in the same site. So, important aspects of this study is the present study has addressed relevant aspects that are not yet fully understood regarding scalar fluxes in the stable boundary layer. And the dimensional analysis here provide has established that there is a threshold wind speed for a scalar gradient destruction. Thank you.
Okay, thank you.